Hey, good morning. This is Mr. Rancourt. I wanted to talk to you about how to read a distance versus time graph and then do a couple examples for you. So the first thing that I need you to understand is that, well, first of all, this is a distance versus time graph. And before you even start to read the story up here, it's important to make sure you understand what's going on in the picture. So the first thing I want to make sure that I review with you is, and I want you to circle whatever I circle, and I want you to write whatever I write, is circle this point right here. And you know from math class that that's called the origin. That's where everything, quote unquote, starts. And yes, although that is true in mathematics and in physics graph, there's something a little bit more to that. And I'll explain what that means here in just a minute, okay? So what a distance versus time graph tells us is that an object is moving away from its home point or its reference point or its origin as time progresses, yeah? So imagine if I were to hit go on a stopwatch, the object would travel in some specific way away from or towards its origin. Okay, and in this case, if you notice, the object is actually starts farther away from its original point. And what I mean by that is this. So the object starts here at 0 seconds, yes, and it actually starts at 1, 2, 3, 4, 5 units away. And as we hit go on the stopwatch, so to speak, it starts to come closer to the origin. And you're probably like, well, no, it doesn't. It's actually traveling farther away. No, that's not true, because the object can't go from here back to here unless we rewind time. And since time only goes forward, it actually does. So this whole area right here, and I want you to highlight it or kind of underline it, but I'm going to actually do it right here. This whole section right here is actually the origin, or the original spot where the object needs to end up, okay? And this will make a little more sense when we talk about what's actually going on in the story. So as time progresses, the object is coming towards this bottom line, or 0x, or the x-axis, yeah? And for some reason, for a specific period of time, it actually stops. It doesn't get closer, and it doesn't travel farther away. So we have to figure out why that is from the story in just a second. And then all of a sudden, after it has stopped for 1, 2, 3, 4 units of time, that could be 4 seconds, it could be 4 hours, it could be 4 minutes, it actually comes back to its original point, or where it needs to end up, yeah? And it does that in a very quick manner. And if you're like, well, how do you know it did it in a quick way? Look at the slope here real quick. If that slope is pretty steep, you know that time is passing pretty quickly and it's getting to its spot pretty quickly. So it has sped up. Yeah, and if you look here, you'll notice the angle or the slope of the line isn't quite as steep. So yes, it was traveling, but it certainly wasn't traveling as quickly as it was from point C to point D. Okay? So hopefully that helps, but let's read the story real quick and let's see if it makes a little bit more sense. So it says an airplane is descending to land at the airport. And the first thing I want you to do above that sentence is I want you to write a line like this, and I want you to write AB. Because this sentence right here explains what's happening from point A to point B, or line segment AB. Okay? Well, let's go back and look real quick. So an airplane is descending to land at the airport. Oh, so this whole thing right here must represent the airport, and we're going to label that real quick. So 0x, or the x-axis, represents the airport, excuse me. So an airplane is descending or going towards the airport in line AB. During its descent, though, it had to fly in circles until landing was cleared of other planes. And that explains what's happening between B and C. So we're going to write line segment BC. And here's what you need to know about planes if you've never flown in one. So sometimes the runway gets too jammed, like a traffic jam of planes, and so they can't have any more planes laying until they get everybody parked and into their quote-unquote parking spaces. So what they do is they have a plane circle the airport, yeah? It doesn't get any closer to the ground, and it doesn't get any higher. All they want it to do is circle. And so that's literally what's happening right here. It's literally circling the airport. And time has progressed as it's doing that. And sometimes you can circle the airport for 45 minutes or an hour. I've done that before, and it's horrible, especially if all you want to do is get home. So from here to here, the airplane is not getting any closer to the ground, and it's not going any higher up in the air. It is literally kind of quote unquote staying put. Okay, so that's what's happening during line segment BC. And then it doesn't really tell us, because it says explain what is occurring during each of these segments. So it doesn't really tell us what's going on right here, and we have to figure that out in just a second. Okay, so here's how you write this. Over here to the side, because it says explain what is occurring during each of these segments. So during line AB, just go back up and give me a quick summary. What does it say? It says the airplane is trying to land at the airport. So let's write that. Airplane trying. We don't need complete sentences here. We just need some notes. Airplane trying to land at airport. And if you look back for segment BC, it says it was flying in circles. So line segment BC is plane flying in circles. Well, it doesn't tell us what's happening from C to D, but I want you to imagine what's happening here. So for a while, yeah, they're waiting for clearance to land, and then all of a sudden, it speeds up and goes down to the airport. Well, obviously that means it's landing, yeah? And you're probably like, well, why are they doing it so quickly? Well, two things. First of all, if you've been circling the airport for, let's say, I don't know, 4 units of time, it's probably a long time, those planes are going to land quickly because they've got a lot of angry passengers in the air. But also, in the mechanics of an airplane, when you are landing, the very last thing you have to do to get the plane to land correctly is you have to speed up. And that's exactly what's happening right here, is it's speeding up as it lands and arrives at the airport. So all we have to do is write landing at airport. And that is all you have to do for problem 1. Let's look at problem 2 real quick. So let's again first look to see what's happening here. Circle the origin. So it says distance from John's home. Well, this must be John's home right here, so let's just label that real quick. John's home. So over time, this object, I'm guessing John, is traveling away from John's home, and he arrives at point A at 1 unit away, and then at B he arrives at 2 units away from John's house, and we'll figure out what those units are in just a second. And eventually all the way, well, excuse me, from B to C he stops. Notice he doesn't get any farther away from home, and he doesn't get any closer to home, but he stops. So we're going to have to figure out why that is. And then all of a sudden from line C to D, he gets to his destination, which is 3 units from home. Let's figure out what's going on in the story. So it says, John left his home and walked 3 blocks to school. Oh, well, these numbers right here represent the number of blocks. So we're going to write that real quick. So in the story, John is traveling from home to school. And let's just write that over here. This is school. And school is 3 blocks away from his home. Now, the question says, what is one possible interpretation of this section of the graph from point B to C? So in other words, I want to know what's going on here. Okay, so let's go through here real quick and let's see if we can figure out what's going on. I'm going to start at the bottom real quick. Look at number 4. It says, John reached the top of a hill. Can you underline that part real quick for me? And it says he began walking on level ground. Well, you should know from the story that all the story said was that he was walking 3 blocks to school. It says nothing about the top of a hill. So this cannot be the correct answer. And I want you to scratch through that. I physically want you to scratch through that answer. And this is why. In your iLearn in the spring, you obviously won't be able to scratch through on the computer, but you're going to have to mentally scratch off the most ridiculous answer, and that is clearly the most ridiculous answer because he's not doing anything at the top of the hill. Okay? Let's keep going. It says Again, remember our goal is to figure out what's happening right here. Yeah, and obviously he stayed or did or waited something, or he's waiting for something right here. So that's what we're looking for in our answer. John returned home to get his mathematics homework. Well, if John had ever returned home, he would be going down this way, or he would be going down this way towards home. Remember, this whole line right here represents home. Well, that's not true either, so we can cross that one off. Look at number 2. John waited before crossing a busy street. Circle that word, waited. Remember, we're looking for anything where he stays put, is stationary, doesn't move, and that is clearly the right answer, so circle that one, okay? Let's just look at number 1 to make sure that we got the right answer for number 2. It says, John arrived at school and stayed throughout the day. Well, that answer is true. He did when he got to letter D, but or certainly that would describe from C to D, but that's not what's describing from B to C. So clearly number 1 is not the correct answer. So number 2 is the correct answer. Okay. All right, so when you're done with this, I want you to show me this, okay? Come up, I'll give you credit for it. And then what I want you to do is I want you to try numbers 3 and 4 on your own. You're going to do it in the same, similar fashion, yeah? And when you get this done, come show me, and I just want to see that you got it correct, yeah? So show me number 1 and 2, and then when I tell you you're okay, go do 3 and 4. Don't do anything with this side yet. We're going to do this together. Got it? Alrighty, thanks so much.